Now, this is officially, this is not really part of functions. You can treat it like a separate chapter, but I like to cover it with functions because there are some questions related to domain and range in this chapter. That's why. So this is modulus slash absolute function. And today's date is the 7th of Feb, 2025. Is there no, there is no difference. It's exactly the same. Paper be same, paper ka time be same. Everything, it's the same. The only difference is the syllabus code. That's it. And that's true for a lot of subjects. There is a difference in math, although a minor difference. But I think as far as physics, chemistry is concerned, I'm not too sure. Okay, obviously I'm not qualified to answer that. But as far as I think they're also the same. But yeah, paper be same. Everything, it's the same. Now, so if let's say this is what modulus looks like. Okay, it's kind of an operator. You know how plus is an operator, minus is an operator, multiply, divide. So this is also kind of like an operator. It takes in values and it does something to those values. So if let's say I take modulus of a negative number, any negative number, doesn't matter what it is, what we get as a result is a positive result. Okay, so if you take modulus of a negative value, what you will get as a result is a positive value. If you take, now if I say modulus or if I say absolute, don't get confused, they both mean the same thing. If you take modulus of a value that's already positive, you will get a positive result. Okay. If you take modulus of 0, what you will get is 0. Modulus basically means that we are interested in just the magnitude. So every value has a magnitude and a direction. So like, for example, if I say 3, so this, because it's positive 3, it has a magnitude and a direction. Direction on the number line. It's 3 units towards the right. This is where it is. Similarly, if I say minus 2 means that on the number line, it's 2 units towards the left. That's where it's at. But when we take modulus means that you're only interested in the magnitude, not in the direction. Which is why when you take modulus of 3, you get 3. When you take modulus of minus 2, you get 2. Basically, that means you're only interested in the distance from the starting point, not the direction. That's what it means. So, like I said, if you take modulus of minus 3, what you will get is positive 3. So if let's say we are given modulus of x, which is equal to 5. Can you tell me the possible values of x? Yeah, this symbol is used in vectors also.
5 and minus 5.
5 and minus 5. Why 5 and minus 5? The correct answer, you're right, is 5 and minus 5. But the reason why 5 and minus 5 are the correct answers is because of this. That is, if you take the modulus of 5, you get 5, or even if you take the modulus of minus 5, then also you get 5. Okay, so this is trying to ask you something, that modulus of what value should give us 5. So we know the answer to that is 5 and minus 5. There's another way to solve it. Okay, one way is that you simply use logic. The other way to solve it is that you square both sides. Okay, so alternatively, what you can do is, if you're given that modulus of x is 5, in order to get rid of the modulus, you can square both sides. And that way you have x squared, which is equal to 25. And then to solve for the value of x, take the square root on both sides, which means x is equals to plus minus 5. Okay, this is the approach that we prefer, is that whenever modulus sign is removed, you have a plus or minus. Okay, so I'm gonna make I'll write down a note that whenever a modulus sign is removed from an equation, there will be plus and minus. Yeah, so 0, obviously there is no sign, so which is why modulus of 0 is 0. Now let's do some examples. Okay, let's do some examples where we solve modulus equations. So example number 1. Let's say we have x minus 3, which is equal to 4. Okay, x minus 3 is just equal to 4. Now, when you remove the modulus sign, a lot of people have this confusion that where does the minus sign and plus minus sign go? You can put the minus sign with the constant. You can put the plus minus sign with the expression that's inside the modulus as well. It makes no difference. Okay, so like for example, as soon as I remove the modulus sign, this is what we get. We get x minus 3 plus minus equals to 4, which means that positive x minus 3 equals to 4 or negative x minus 3 is equals to 4. ठीक है, हम ये भी कर सकते हैं. Or what we can do is we can do x minus 3 equals to plus minus 4. That is something that we can also do. It makes no difference. Okay, where you put the minus sign makes no difference. A lot of people prefer this because it's more convenient when you have the plus minus sign with the constant. So that means x minus 3 could be equal to 4 or x minus 3 could be equal to minus 4. So x is equals to 7 or x is equals to minus 4 plus 3, which is equal to minus 1. What about pi? Modulus of x equals to pi for this. Yeah, of course, pi is just like a constant. Okay. Pi is just like any other constant. Let's do another example. Let's say we have modulus of 3x minus 1, which is equal to 5. Okay, and this is what we're supposed to solve. So as soon as you get rid of the modulus sign, you have a plus and minus with the constant. So 3x minus 1 equals to 5 or 3x minus 1 equals to minus 5. Then you can solve this like a normal equation. So you have 3x, which is equal to 6, which means x equals to 2. And then you have 3x equals to minus 4, which means x is equals to minus 4 upon 3. Now, graphically speaking, how come we're getting two different values? Normally, when you solve a linear equation, if let's say you solve 3x minus 1 equals to 5, you get one value. How come we're getting two different values over here? What's the logic behind that? Question for you guys. What's the logic behind that? No, it's not a quadratic. It's not a quadratic. That's not the correct logic. There's some other reason why we're getting two values. Why is different? Okay, I understand why is different in both cases. I agree why is different, but technically inside the modulus, we have a linear equation. Technically, inside the modulus, we have a linear equation which is equal to a certain constant, which when we solve, we get two different values. So how come we're getting two different values? That's what my question is. Because only positive I values? Think of it graphically. What does a modulus do? A modulus takes negative values.
With two different lines.
Sorry? Can you repeat that? Can you repeat that? The two different values could represent the vertices of the mirrored graph. Yes. So basically, when you plug in a negative value inside the modulus, it turns positive. When you plug in a positive value inside the modulus, it remains positive. So every time you have a straight line, doesn't matter whether it's upward sloping or downward sloping, that means it's going to go below the x-axis, meaning y is going to be negative. But when you apply modulus, what happens is that part becomes positive. So that is why when you're solving an equation, you're likely to get two different answers. Okay, we're going to see this. I was just curious if you guys know the answer to it already. We're going to find out. We're going to learn how to sketch modulus graphs, and then we're going to see why we get two different answers. But before we learn how to sketch it, I want you guys to first take a look at what exactly happens in the background. So let's say you have y is equals to x minus 3. Okay, something normal, nothing new really. But what if I take the modulus of it? Notice now it has become a V-shaped graph. Okay, so let me draw a graph without the modulus so you guys can see the difference. So here you can see y equals to x minus 3 is this graph, is the graph in red. Okay, then as soon as I take the modulus, what happens is it only affects the part that's below the x-axis. Why? Because here on this part of the graph, on this part of the straight line, you can see all y values are positive. But below the graph, you can see that all the y values are negative. And what modulus does is it turns the output positive. Output, as we know, are the y values. So when the outputs become positive, so you can see what was -3 has now become +3. And similarly, what was, let's take any other point. Let's take this point, for example. At 2, we had -1 here. And now this has become 2, 1. So how do we draw a modulus graph? That's what we're going to find out. Now, before we learn how to do that, I want you guys to make an observation. No matter what type of modulus graph we have, there is one thing common in all the graphs. What's that? Let's say we have 2x minus 1 inside the modulus plus 3. Let's say we have y equals to minus, then modulus x minus 2, just totally random, okay? X minus 2 inside the modulus plus 5. V shape, that's correct. So all these graphs have something that we call a vertex. क्या बोलते हैं हम इसको? हम बोलते हैं इसको vertex. So no matter, as long as inside the modulus you have a straight line equation, as long as inside the modulus you have a linear equation, you will notice that every graph, doesn't matter whether it's a minimum or maximum natured graph, it will have a vertex. Okay, so every modulus graph, if it has a linear equation inside the modulus, is going to have a vertex. What happens if it doesn't have a linear equation? Let's say it has a quadratic equation, or let's say even a trigonometric equation. So that means we're just going to take the negative part of the curve reflected above the x-axis. So let's say you have modulus of x squared minus 5x plus 6. So here, let me hide all the other graphs so you can see that this graph was meant to be like this, but because of the modulus, it is now reflected. The part that's below the x-axis has been reflected above the x-axis. That's what modulus basically does. The part that's below the x-axis gets reflected above the x-axis. Now let's see formally. Can we say both are images of one another? Reflection, yes. They're reflections of one another through the line x equals to b. Yes, we can say that. So now let's learn how to sketch modulus functions. Okay. And the following rules that we're about to write down only apply to these kind. Y is equals to, let's say you have A and then you have bx plus c plus d. Okay. So you have a linear function inside the modulus. So the following rules that we're going to write down apply to these kind of graphs only. Okay, so remember these graphs are always going to be V-shaped, either something like this or something like this, always. Yes, not tested that much, but they're part of the syllabus. So we're going to learn this with the help of an example. Okay, we're going to learn this with the help of an example. Remember, this is called the vertex. So let's say the question is y is equals to modulus of x minus 2. Okay, you have to sketch the graph y is equals to modulus of x minus 2. We know very well that it's going to be something like this, but we have to properly sketch it, as in we have to find out all the points and then join them and get a straight line. So how do we do it? Well, here's the first step. Step 1. Step 1 is that we find the x coordinate of the vertex by equating the expression inside the modulus to 0. Okay, so I repeat, We find the x-coordinate of the vertex by equating the expression inside the modulus to 0. So let's do that. Very simple. X minus 2 equals to 0, x equals to 2. So we have the x coordinate of the vertex. Now, if I want the corresponding y coordinate, what do you think I'm going to do? If let's say you have the x coordinate of the turning point and you want to find out the corresponding y coordinate, what do you have to do? Or let's say you have x coordinate of any point and you want to find out the corresponding y coordinate of that point, what are you going to do? You're going to plug it back into the equation. Okay, so here's step 2. And step 2 is find the y coordinate of the vertex. How? By plugging in the x coordinate of the vertex found in step 1. Okay, so let's do step 2. So this was the equation, y is equals to modulus of x minus 2. We found x to be equal to 2. So y is equals to 2 minus 2. What's 2 minus 2 equal to? That's equal to 0. So what do we have now? We have the coordinates of the vertex. They are 2 comma 0. Let's write them as v. They are the coordinates of the vertex 2 comma 0. That means as far as the sketching part is concerned, here is where we are. Here's the x coordinate. Here is the y coordinate. So as far as the sketching part is concerned, what we have done is we have found out the point where the graph will turn, or the vertex. Okay, now we know looking at modulus graphs that we're going to have a straight line over here, we're going to have a straight line over here. Okay, that's it. We're going to have a straight line over here and a straight line over here. So how will we find out the points of that straight line? Notice that in order to make a straight line, we need a minimum of 2 points. Yes, we find out 3, but 2 points are more than enough. So that means I already have 1 point. If I can just find out 2 more points, I can make this straight line. And then similarly, if I can find out 2 more points on the other side, I can make the other straight line and we can have our modulus graph. So what do we do? For that comes step 3. Now these steps, these detailed notes are for you guys. You don't have to, write this all down in the exam. They're just for you so that when you're revising or when you're learning the concept, you can go through the notes, and then once you've memorized them, you can be independent. So plug in 2 values of x greater than 2, why 2? Because 2 is the x coordinate of the vertex, and 2 values lesser than 2 to find the points on the lines. So what we're going to do is we're going to make a table, and in the table, so here's our table. So here's x, here's y. Now the x coordinate of the vertex, in fact, the vertex itself is going to be right in the center. Okay, so that's 2, and the y coordinate is 0. So we're going to plug in 2 values greater than the vertex. That means let's plug in 3, let's plug in 4. What happens if I plug in 3? And remember, where are we plugging in? We're plugging it in this equation. So if I plug in 3, 3 minus 2 is 1, and 4 minus 2 is 2. And the other 2 values that I have to plug in are 1 and 0. If I plug in 1, be careful. So we're going to do y equals to 1 minus 2. 1 minus 2 is minus 1. Then we take the modulus of it, so it becomes 1. Similarly, if you plug in 0, 0 minus 2 is minus 2, but once you take the modulus of it, you get 2. Now, how do we put this all together? Here's how we put this all together. I want you guys to pay very close attention. So we have all the necessary details. And yes, we're sketching, but still try and be as accurate as possible. As in when you're, although you will be given the grade in the exam, even for sketching. But if let's say you're not and you have to draw it yourself, then make sure that the x and y values are equally spaced out. Okay. Now, first thing that you're going to mark is the vertex. Okay, so that's right here. This is the vertex. Now, here's what I'm going to do. This part of the graph, I'm going to draw in blue so you guys can see. So here's the vertex marked, and the other point is 3, 1, and the other point is 4, 2. So that means we're gonna have a straight line over here. You can extend the straight line, make sure that's passing through the 3 points. There you go. Then there's this part of the curve, or this part of the modulus graph, where the coordinates are 1, 1 and 0, 2. So we're gonna draw a straight line over here. And that's it. This is what the graph of y is equals to modulus of x minus 2 looks like. Now, we will do more examples, but right now I want you guys to take a very good look at it. Let me know if you have any questions. I'll summarize this. Yes, Varad.
Sir, what if we didn't take the x coordinate for values lesser than 2 as 0? Then we wouldn't have found the y-intercept because it's not accurate.
Normally, the question will ask you to draw, whenever there's a sketching question, the question will ask you to show the intercepts clearly. Every time there's a sketching question, the question will ask you to show the intercepts clearly. So it's okay if you didn't, then make sure that you find it out separately and show it on the sketch. If let's say you didn't take 0, 2, that's fine. Then make sure that you find it out separately and you show it on the sketch that that's what the y-intercept is. Okay, does that answer your question?
Yes, sir.
Okay, now I'll quickly summarize this. So sketching modulus function, but right now we're focusing on modulus linear functions, meaning inside the modulus, you're going to have the equation, something that looks like the equation of a straight line. Okay, y equals to mx plus c sort. So remember, every time you have a modulus linear equation, this is what it's going to look like. It's going to have a vertex, doesn't matter where or what the values are, but it is going to have a vertex. And then it's going to have a straight line on the right-hand side of the vertex and a straight line on the left-hand side of the vertex. Our job is to find 3 things. Number 1, find the coordinates of the vertex, find a few points on the line that's on the right side of the vertex, find a few points on the line that's going to be on the other side or on the left-hand side of the vertex, okay? So here's what we do. How do we find out the coordinates of the vertex? Whatever is inside the modulus, you equate that to 0. So we get x equals to 2. You plug that in back into the equation to find the y coordinate of the vertex. Now we have a complete point. This is the vertex. Now we need some points on this line, some points on this line. If I want some points on this line, that means I'll have to plug in values of x that are greater than 2. So we plug in a few values of x greater than 2. Then we want some points on this line, which means I have to plug in some values of x that are lesser than 2. So we plug in some values of x lesser than 2. That's it. We join this two straight lines and we get our answer. So can we take any points greater than 2? Yeah, any points greater than 2. Because you want to make a straight line, right? So if you want to make a straight line, you want values that are greater than 2. So you can mark the points and make a straight line. That's it. Okay, let's do another example. Let's do another example. This time, obviously, we're not going to write down the step-by-step note. We're just going to do it directly. Yes, there are quadratic modulus as well. Those are actually easier. Quadratic modulus are much easier than linear modulus because there's not a lot of working. So x plus 3 plus 2. First step, find out the x coordinate of the vertex, for which we take whatever's inside the modulus, equate that to 0. So x turns out to be minus 3. Then to find out the y coordinate, we plug in this into the modulus equation, into the original equation. So minus 3 plus 3, that's going to be 0, 0 plus 2. That means the y coordinate of the vertex is 2. So here we have the coordinates of the vertex, minus 3, 2. Now what do we want? We want some points that are greater than minus 3 and some points that are lesser than minus 3. You can do it directly in your calculator, or if you don't have a calculator, if let's say this comes in a non-calculator paper, then do it using a table. So put minus 3, 2 in the center. Here we go. Now let's plug in 2 values greater than minus 3. Let's plug in 2 values lesser than minus 3. So greater than minus 3, that could be minus 2, minus 1. Let's plug in minus 2, minus 1. So minus 2 plus 3 is 1, modulus of which will also be 1. 1 plus 2, that's equal to 3. Minus 1 plus 3 is 2, modulus of which will also be 2. 2 plus 2 is equals to 4. Then let's plug in minus 4. Minus 4 plus 3 is minus 1. Modulus of 1 is 1. 1 plus 2 is equal to 3. Then let's plug in minus 5. Minus 5 plus 3 is minus 2, modulus of which is 2. 2 plus 2 is equal to 4. Sir, do we need to do this as... Dekho, we are making a sketch, but we still want points, right? We still want points. So we try and be as precise as possible. And a lot of times in the question, you will be given a grid. Okay, I'll show you some questions which I have taken out for today's class. So like, for example, this. Okay, so you have to, even though it's a sketch, but you still have to mark values accordingly. So we're going to solve this, don't worry. But yeah, still try and be as accurate as possible. Why did you plug modulus 0 in that equation and not minus 3 in place of x? I plugged in minus 3. Minus 3 plus 3 gave me 0. I did plug in minus 3. Minus 3 plus 3 gave me 0. And that's how we got 2. Okay, so I hope that answers your question. Now, minus 3 comma 2. So like I said, even though it's a sketch, try and be as accurate as possible. Here's minus 1. Here's minus 2, minus 3, minus 4, minus 5. Now, minus 3 comma 2, that's the vertex. So that means we're going to have a straight line here and we're going to have a straight line here. Okay, so let's plug in minus 2. So at minus 2, we got 3. That means somewhere over here. At minus 1, we got 4. That means, although we didn't plug in 0, but if we plugged in 0, we would have gotten 5. So here's the straight line that's on the right-hand side of the vertex. Then at minus 4, we got 3. At minus 5, we got 4. So here's the straight line on the left-hand side of the vertex. That's it. Job done. Okay, make sense? Yes or no? Let me know if you have any questions. Okay, great. Now, here's another question, but this time there's a twist. This time we have a quadratic function inside the modulus, and we can also have a cubic function inside the modulus. Yes, Murad.
Sir, how to know what the shape of the graph will be?
Okay, good question. Just a minute. So it's always going to be V-shaped, right? It's always going to be V-shaped. But let's understand a pattern. So notice if we have a positive sign outside the modulus, so we can say it's kind of like a minimum graph. Okay, not a minimum curve, but it's a minimum graph. But if you have a minus sign outside the modulus, what is that like? That's an inverted V. Okay, so with the positive sign, it's going to be a regular V. With the negative sign outside the modulus, it's going to be a 180-degree rotated V. Okay, I'll add that to your notes. Okay, I'll add that to your notes. So the right side of the vertex always represents the positive answer of the modulus. What do you mean by that? I'm not sure if I understand what you mean by that. Where should I add it? Yeah, I'll add it over here. So this is when you have a positive modulus, and this is when you have a negative modulus. Mohammed Ali, I'm not sure if I totally understand your question, so if you can elaborate, that'll make it easier for me. Okay, in the meantime, I'm solving this question. Let's say you have y is equals to x squared minus 4x plus 3. So whenever you have a modulus graph, which is not a straight line, inside the modulus, if you don't have a straight line, then here's what you have to do. Forget about the modulus. Okay, not entirely. I'm not saying that you completely ignore the modulus. I'm saying that, for a few minutes, forget about the modulus and sketch it like you would sketch any other quadratic curve. So how will we sketch this quadratic curve? What are all the things we need in order to sketch a quadratic curve? We need the x-intercepts. So let's find out the x-intercepts by equating it to 0. Okay, you guys know how to factorize a quadratic equation. When you do that, you will get two x-intercepts, x equals to 1 or x equals to 3. Okay, so these are your x-intercepts. Then what's another very important thing that we need, perhaps the most important when we are sketching a quadratic curve? What's the most important thing that we need? Let's see if you guys remember. In order to sketch a quadratic curve, turning point. That's correct. Okay, yeah, we need nature. Yes, nature, we can figure out it's a minimum curve. Yes, you're right. But another most important thing that we need is the turning point. So let's find out the turning point. We will use the method that we learned in math to find out the x and y coordinate of the turning point. So what do we add? We add the square of 2 and we subtract the square of 2 as well. So we get y is equals to x minus 2 the whole thing square, 3 minus 4, which is equal to minus 1. So that means the coordinates of the turning point are 2 comma minus 1. Yeah, you can do dy by dx also. Okay, if you know differentiation, go ahead, you can use differentiation as well. In fact, after a certain point, I've noticed that students just completely ditch the idea of bringing it in completed square form and use differentiation. And I think that makes total sense because differentiation is much easier. Unless you have to, unless there's a part in the question where you have to show, you have to bring it in completed square form and, show your answer, then of course don't do that. So we have all the things that we need. We have the nature, we have the x-intercepts, we have the y-intercepts, we have the turning point. So let's start with the y-intercept. You can start with whatever you want really, which is 3. The x-intercepts are 1 and 3. The x coordinate of the turning point is basically 2 comma minus 1. So let's put together a nice curve. This is what we get. Remember, it's a sketch, but still try and be as accurate as possible. There we go. Now, what should we do? What will be the impact of modulus on this graph? Question for you guys. What will be the impact of modulus on this graph? What do you think? That is correct. We know modulus only works on negative values. Okay, so this part is positive, nothing to worry about. This part is positive, this is safe from the modulus. But this is the part that the modulus function is going to attack. And by attack, I mean not literally attack. By attack, I mean it's going to affect it. So this part of the curve will now be reflected above the x-axis. Okay, so all we need is a point. So we can take the turning point, which is 2 comma minus 1. Now this 2 comma minus 1 will become 2 comma 1. And this is what we have now. That's it. So this is the final graph. And when you're done, don't forget to erase this part. Either erase it altogether or make it dotted. Okay, my suggestion would be to erase it altogether. And there you go. This is what we have now. Okay, lekin, I'll leave it dotted so that later on when you guys are revising, you can see what I have done. Okay, so I'll add this to your notes also, that this part of the graph gets reflected above the x-axis. Yes, basically x-axis means the equation is y equals to 0. So what about the small part on the, are you talking about this? Okay, this will not change because remember, it's everything that's below the x-axis that's going to be reflected above the x-axis. Everything that is below the x-axis. So this is not below the x-axis. Here, it doesn't matter if x is negative, that's not a problem. It's y that shouldn't be negative. So if you extend this, y will remain to be positive. Similarly, if you extend this, y will remain positive. Not a problem. Okay, so problem is that y should not be negative. X can be negative, that's okay. All right, all good? Now let's do some, we have time, let's do some past paper questions. If it's minus x squared, then the x-intercepts become vertices. Yes, that's correct. If it's minus x squared, then x, that's correct. Okay. So here's a question, which is a mixture of modulus and domain range. Given that each of the following functions is defined for the domain, x is greater than or equal to -3, lesser than or equal to 3, find the range of f of x. So the first part is a no-brainer, right? First part is a no-brainer. So here's what we're going to do. Let's plug in -2. So we get 2 into -2 minus 3 into -2. So 3 into -3 into -2 is 6. 6 plus 2 is 8. Sorry, 8. Okay. Then let's plug in 3. So 2 minus 3 into 3. 3 times 3 is 9. 9 minus, so 2 minus 9 is -7. Okay, so we don't have to worry about the function turning or anything of that sort. So that means we can give the range quite simply and write it as lesser than or equal to 8, greater than or equal to -7. Okay, any questions so far? Okay, now I have a question for you guys. By nature, what kind of a function do you think this is? Any modulus graph, by nature, what kind of function do you think this is? Is it a one-to-one or is it a many-to-one? This is a one-to-one? Are you sure it's a one-to-one? It's a many-to-one. Okay, it's not a one-to-one, it's a many-to-one. Why? Because there are many x values that give us the same y value, or it doesn't pass the horizontal line test. Therefore, it's a many-to-one function. Okay, I hope that's clear. If it was just a straight line, it doesn't matter whether it was upward sloping or downward sloping, that would be a one-to-one function, but this is by default a many-to-one function. Okay, now here's part 2. Part 2 is a little bit tricky. Why is it a little bit tricky? Because we now have a many-to-one function. Okay, remember, this is a one-to-one function. This could potentially be a many-to-one function. Why am I using the word potentially? Because it depends on the domain. The domain will decide whether it's a many-to-one function or a one-to-one function. Naturally, it's going to be a many-to-one, but the domain will decide further whether it's a one-to-one or a many-to-one function. So your safest bet is always what? Whenever you're finding out range of a many-to-one function, potentially, your safest bet is to always make a rough sketch. Okay, I repeat, rough sketch. You don't have to be too precise, but just make a rough sketch. So tell me, what do you think will be the x coordinate of the vertex for this? What will be the x coordinate of the vertex for this? 2 minus 3x. 2 upon 3. That's correct. And the y coordinate, that's going to be 0. So here's 1, here's 2. 2 upon 3 means somewhere over here. Okay. Now let's plug in. Keep in mind the domain. Okay. So since we are given a specific domain, let's plug in the end value. So we have found our vertex. Okay. We found our vertex. Now let's plug in the endpoints, meaning let's plug in 3 in the function. Let's see what we get. So 2 minus 3 into 3. So we saw earlier that this is -7, but because of the modulus, it's going to be 7. And then let's plug in -2. So 2 minus 2 into -2. This is going to be equal to 2 times, sorry, this is 3. -3 times -2 is -6. 6 plus 2 is 8. Sorry, -3 times -2 is 6. 6 plus 2 is 8. So that means if we plug in 3, what do we get? We get 7. So that means somewhere over here. Okay, it's a rough sketch. And if we plug in -2, we get 8, which is going to be somewhere over here. We're making the sketch not because we're asked to, we're making the sketch so that we can very easily find out the range. So this is what the graph looks like. For the given domain, this is what the graph looks like. Okay, I'll repeat. So here's what we did. We found out the vertex. We plugged in the very end value of the domain, and we plugged in the other end value of the domain. Okay, one corresponding value is 7, the other corresponding value is 8. Now, what if I ask you guys to now tell me what is the range of g of x? Tell me now, what is the range of g of x? Question for you guys. Look at the graph and tell me what is the range. I think I've made it very easy now. Anyone can answer this question. That's correct. From 0 to 8. Okay, so the range is greater than or equal to 0. Why? Because this is the minimum point. Now, why did we plug in the end points of the domain? We plugged in the end value so that we can find out the other extreme. We can see the least value, but how do we know which value carries which value of x will give us the greatest y value? So for that, we plugged in the two endpoints and we got 8 as our answer. So there you go. That's the range. And you couldn't have done this without making a rough sketch. Okay, I repeat, don't think that just because it's a 2-mark question, you don't have to do a lot of working. You still have to do it to make sure you get the correct answer. Okay, I'll explain this again. Now, first of all, why are we inclined towards the idea of making a sketch? That's the question that we all should answer first. The reason why we're inclined towards the idea of making a rough sketch is because modulus functions are inherently many-to-one functions. Okay, why? Because they decrease and then they increase. Or it could be the other way around, that they increase and then they decrease. So that means every time you have to find out the range of a many-to-one function, the best way to do it is to make a rough sketch. So we make a rough sketch. How do we make a rough sketch? We find out the vertex. The slight modification that we do is we don't plug in values greater than the vertex. We simply plug in the extreme value of the domain, the extreme values of the domain. So we plug in 3, we get 7. So हमारे पास ये वाली line बन गई. We plug in -2, we get 8. तो हमारे पास vertex के left hand side वाली line पूरी बन गई. अब हमें इन y values को और ग्राफ को सामने रखते हुए रेंज बतानी है. So we see that the minimum y value is 0. What's the greatest y value? It's not 7, it's 8. So that means this is the correct range. Okay, I hope it makes sense now. Now I want you guys to try part 3 yourself without my help. Let me know if you can do it. And then if time allows, we'll do another question. Okay, I'm just going to grab a glass of water. I want you guys to try part 3 yourself. So it's 2 minus modulus of 3x. So the coordinates of the vertex, I'm sure everyone figured that out correctly, 2, 0. Now, remember the domain is from -2 to 3. This is h of x. So let's plug in. Let's find out h of -2. That means 2 minus 3 into -2, that's -6. Modulus of -6 will be 6. 2 minus 6 will be -4. Then let's find out h of 3. That means 2 minus 3 times 3 is 9. So modulus of 9 is 9. 2 minus 9 is -7. Yeah, 0, 2. Sorry, 0, 2. You're right. Okay. Now let's make a rough sketch. So 0, 2 means somewhere over here. Okay. Now when you plug in 3, you get -7. Okay, remember it's a rough sketch. So here is one straight line. Then when you plug in -2, you get -4. So here is the other straight line. So naturally, it turns out to be a maximum shaped curve. Okay, it can only be, it's not like it may be a minimum natured graph and you might accidentally make it maximum. 9. If you've gotten the points right, it will automatically turn out to be the correct natured graph. Okay, now looking at this, what's the range going to be? Let's see. So h of x is greater than or equal to -7. Okay, and lesser than or equal to 2. That's correct. Why? Because this is, as we all can see, the maximum value, and this is, as we all can see, is the minimum value. Okay. Now, see if you guys can answer the last part. Which of the following functions f, g, and h has an inverse? What's the condition for having an inverse? Can we take inverse of any function? It has to be a one-to-one. So which one of the three are one-to-one? Which one-to-one only? That's correct. So which function do you expect? That's correct. So the answer to part 3 is only f. Why? Although it's not asking, but if let's say it did ask, we would say that it's because it's the only one-to-one function here. The rest are many-to-one. So why isn't minus part reflected here? Because here, okay, notice that we have a minus sign before the modulus. So that means while the end result of modulus of 3x will be positive, but when that gets multiplied by minus, it will all become negative. Okay, that's the reason why.